Okay, I have to
已经启动了会议录制。
arrange another thing, introduce assignment 4. Actually, from now, we have already arranged assignment 1, 2, 3, and project 1. And also, I have already provided the instruction, step-by-step demonstration about each of the assignment or project. And today, we will release our we will release the problem set or assignment 4. Assignment 4. Okay, so let's just go through the description of this assignment, and later I will share this file to our WeChat group. Okay. And problem set 4. This problem set will introduce you to using control flow in Python, blah blah blah, and give you a chance to explore the section search, by section search. And collaboration is the same as the previous one. And the topic of this chapter is cipher like Caesar. Which one is kind of how to create like a password from the plain text. I mean, create a password, how to encode your plain text, plain message into the pass secret message. So this is the purpose of this assignment. So let's look at the description about this topic. Everyone to relive the glory days of your youth and pass secret message to your friend. So this is the chance. There are several tasks you have to implement here, or like different tasks. Encryption and decryption. Encryption means that the process of obscuring or encoding message to make them unreadable. Decryption means that to decode the message from some unreadable message that you have already encoded. So cipher means the algorithm, the encryption algorithm for performing this encoding and decoding. Cipher text, plain text means the original message, and cipher text means the encrypted message. So this is the idea of this GISA cipher. Idea of this one to pick an integral and shift every character or every letter of your message by this integral. If you have integral like 2, and the original A will become C, and original Z, I mean the final, I mean the last character will become like B, like this kind of thing. If the shift is like a right shift. So this is the meaning of this GISA cipher. Okay, and they provide some example with the plain text and the shift and the cipher text. The shift is the cipher, okay, and plain text is like A, B, C, D, E, F, and with the shift of 2, so it will have a encrypted text as C, D, E, F, G, H. Like A becomes C, B becomes D, C becomes E, and F becomes H, because we shift each of the characters with 2. Okay, hello world will become this one. Actually, this one is already very difficult to read, right? With shift 4. If the plain text is empty, like always like blank or some operator or signals, they will be the same as the previous one. Also, like if they have like comma or this kind of signs, they will the same as before. So this is an example about this ciphertext. Yes, cipher encoding method. Okay. Our task is to implement this one in your, in your project, in one of your projects. This is some step-by-step instruction about how to finish, how to complete today's this assignment. Firstly, is that maybe you have to create several classes with inheritance, because we have already learned the principle of inheritance and a different level of classes. So this is the chance that you can experience this kind of classes with parent class and subclass. We will have a message class as the parent class, as the base class, and two subclasses, plain text message and ciphertext message. The parent class contains methods that to be used to apply a cipher to a string, either to encrypt or to decrypt a message. Plain text message has methods to encode a string using a specified shift value. Our class will always create an encoded version of the message and will have methods for changing the encoding. Ciphertext message contains a method used to decode a string. When you have completed your implementation, you can either create a ciphertext message instance using the encrypted string that someone provide you and try to decrypt it, or you can encrypt your own plain text message instance that create a ciphertext message instance from the encrypted message within that plain text message instance and try to decrypt and see if it matches the original plain text message. So this is the description about the requirement. So your job will be to fill methods for all three of these class according to the specification given in this document. And I will provide this ps.py file as the to provide some comments and documentation information for you to make you better implement your source code, or maybe provide you like a skeleton, or provide you a framework for you to fill in like your source code into the project. So please remember that you never want to directly access attributes outside of a class. I think this, this point I have also mentioned several times, that do not directly get access to the values of the variable in of an internal variable in the class. It's better to use the getter and setter method, because like the class of ciphertext message, inside of the ciphertext message, you may want to like store, or you may want to save the original text message inside, but you really don't want to you really don't want to let others to get access to this kind of information, because this should be secret. This should be some kind of secret. So it's better to use getter and setter methods. A getter method should just return an attribute. A set method should set an attribute. Although this seems simple, we need these methods in order to make sure that we are not manipulating attributes we shouldn't be. This is the principle of object-oriented. So directly using class attribute outside of the class itself, instead of using getter and setter, will result in point deduction, and more importantly, can cause you headache as you design and implement object class architecture hierarchies. Okay, so there are some. This is one important point here, and there are some other hints we can provide here. Firstly, there are a couple of helper functions that we have already implemented for you. Load words and is word. You may use them in your solution, and you do not need to understand them completely. You can use that. Okay. You can read the associated comments here, and you should read and understand the helper code in the rest of the field and use it to given to guide your solution. Another one is message. Field in the methods of the message class found in ps4b.py according to the specification in the docstring. And we have already provided a framework about the message class and for functions. So you have to implement them. Firstly is the initialization, the constructor of this class. And we have provided the signature of this class with one explicit parameter text, so that you can using a string to initialize your class, okay, your message class, and get message text, get valid word, build shift dig, and apply shift. This kind of functions that we have provided comments, and you have to implement them by yourself. Okay. Another one is plain text message, and this class is also written in this file, and also we provide a framework with several signatures of functions, including the init function, including the get shift and get encryption, dig function, and message and change shift and other kind of functions. And another one is ciphertext message class. Also provides several functions with you. Okay, several signatures of functions to you, and you can try to implement them one by one. And another part is testing. For the testing, you have to read this the instruction and try to write a main function. If name equals main, and try to write some test case for your project to see that if your source code can run well and can function well. Okay, so this is the requirement about this assignment 4. Actually, this assignment 4 is a little bit big than the previous one, and as you see, it includes several class and inheritance. But I think it's okay for you to implement all of the functions, because we have just finished chapter 9, and like including a lot of information and knowledge about the inheritance and its concept and the principle of object-oriented programming. So, and also this method, this encryption method, is not very difficult to implement. Just some kind of character shift, right? From A to C, from B to D, like this kind of thing. So it's very easy to implement. So and this one is very interesting, and please implement this one. Okay. So this is our assignment 4. I think we don't have enough time for another assignment. Maybe we can only provide this assignment from assignment 1 to assignment 4, and project 1. And at the end of this course, this object-oriented programming, maybe in next week, at the end of next week, I will release another project. It should be project 2. But for project 2, I will have no time to like provide a solution instruction step-by-step demonstration about this one. But don't worry, the project 2 should be this, some kind of project that was described in our textbook. So you can, I mean, you can implement the project 2 step by step by watching or by reading our textbook chapter 16. So you can implement that. That will be the another very interesting project. That project is mainly about an instant message chat, network chat room or network meeting room, and that is a web service that you have to implement. In the web service, you have to create a server and create some client, client suite or client program to log into the server. Inside of the server, you can like send message to each other, or send a public message, or send private message to other people. So that is the project 2. Okay. I will release the detail of that project in next week. And for all of these, assignment 1 to 4 and project 1 and project 2 should be quite important to like measure your final, to evaluate your performance or evaluate your final score about this object-oriented programming lecture. And so please take care, and please be careful, and try to implement all of the requirements in our assignment and project. Okay. And let's begin today's lecture. Let's begin chapter 9 or chapter 16, network programming. Why we choose this chapter as an option? Because currently, as we all know, that the computer network or internet plays quite a critical role in society. They allow for information to be transmitted from like one computer or another device to other device, forming the basis for like email, web browsing, like main page of some kind of website, or chat room, as we mentioned before, like WeChat or other kind of instance message software, and many other network applications, including some kind of mobile phone applications. I think all of the, today's application, modern application or software should require the user to get access to the internet so that they can like provide more information or provide more service. Okay. And it's hard. Network connection is another method of input and output, just as our programs use like print and input to interact with a local user in a disk, or use write and read to get information into and out of a file. Network connection allows us to send information to another computer, or to receive information sent by that computer. So that's the network do. So in this chapter, we we include several topics, introduce several tools to support network programming in Python. Actually, Python provide like third-party library or internal library, a lot of this kind of library for network programming. Okay, and we demonstrate working implementations for simple forms of several applications, including like a web browser, web server, chat room, and even our own network search engine. Maybe I don't think maybe we have enough time to like implement this kind of network search engine, but chat room, web server, and web browser, I think I'm sure we can try to implement some important, some simple, simple this kind of application about with the function of like web browsing, web server, providing the contents like page or like some kind of HTML page or chatting room service to the user. Okay. And this is the first topic about network programming. We need to describe how network connections are established and how programs communicate. Like when you type the one website like www.security.edu.cn or google.com or some IP address into your web browser, communication takes place behind the site to bring you to the design information. This string of characters is known as an URL, Uniform Resource Locator. Like this example and this example. They are URLs. The Uniform Resource Locator serves as a general identifier for the network resource. This like www.google.com portion of that URL is termed host name and symbolize a machine somewhere on the network. Host names are chosen to be memorized by humans but have little to do with the true locations of underlying machines. I mean, behind the screen or behind the scene, network connections are established using a number known as an IP address. As we can see here. This one and these two examples are different. They are URLs, and this one is IP address. But all of this kind of, this kind of information can provide your web browser to get access or connect to another people's or to connect to another server, another machine. Okay. Usually we use the URL or like host name or this kind of like www.something.com, this kind of thing, because they are quite easy to be memorized or memorized by humans. However, in the under the very low level of the, it's okay. Yeah, under the very low level of the network connection, the machine usually use the IP address, like this 4 digits, 5 digits combined together. Actually, there are some kind of knowledge in computer network or computer network. This kind of courses. This is not including in our object-oriented programming, but I have to mention that because in this chapter we are trying to use some knowledge about this network and internet thing. Okay, and to translate the host name to its underlying IP address. Your computer will query a special computer on the on the internet, known as a DNS, domain name server. Okay, DNS. The HTTP portion of the URL denotes a particular network protocol that will be used for the transmission of information. This one HTTP, this one HTTPS. In this case, the HTTP is short for Hypertext Transfer Protocol, okay? Or the Secure Hypertext Transfer Protocol, HTTPS. The protocol specify convention for the transmission of data. Since networks are used to transmit many different kinds of information, the sender and receiver must have an agreement as to the particular format that will be used. The protocol used for requesting a web page is different from that used to send email or to stream the video. Because this one is like mainly for the hypertext or like this kind of hypertext, which means like with text and some formatted text, image, pictures, or some kind of tables, and maybe like graphs, and maybe with some links, this kind of thing. If the two machines are not using the same protocol, they cannot efficiently or effectively communicate, much like two people speaking like different languages. Because this many different protocols exist, a machine will open execute different software depending upon which data format is being used. To help quickly segment incoming network traffic according to the protocol, each network connection to a remote machine must be designated at a specified port. A port is really just a number of range from 0 to 65,000 and like 535. This is the port. Usually, the port will be designed with a specified number, and the number usually represents different kind of protocol. Like 18 usually means HTTP. 8080 usually means HTTPS. Maybe like some other like 22 or 20 means something else. Okay. Okay. The web service are typically sent through port 80, and the machine might automatically handle network traffic from this port with software designated for HTTP activity. Usually for this IP address, this one is the address of the host or of the server, and this means different types of service or different types of protocol here. Okay, so this is the IP address and the port of the address. Okay, and to manage the use of a specified network connection, programmers rely upon an abstraction known as a socket for the connection between two machines. Separate the sockets here. network socket. A separate socket is maintained at each end, used to track the incoming and outgoing data for the machine. As a programmer, the socket serves as the interface for sending or receiving data from the opposite machine. In Python, this model uses a socket class, which itself is imported from the socket model. Usually, the invoke of this socket model and socket class is like this one. We can instantiate such an object as this. Okay. And this socket is not yet connected to any remote machine in this. When we create a socket here, like from the first and the second line, at the beginning, when we create or instantiate this socket into this variable s, the S is not yet connected to any remote machine, and we have to use this behavior, the connect behavior, to connect our socket into like this host. This one is URL host and this port. Okay. And the socket class supports a variety of behaviors, although we will only use the most basic ones like connect. And we have summarized some basic behaviors in next page. As we see in this example, the connect function or connect behavior is used to open a network connection to a remote host. In this function, we must specify both the host address and the network port number. This is done by calling the connect method with a single parameter that happens to be a host and a port tuple. You must be very careful that connect function have only one parameter here. This is one parameter. This parameter is a tuple. A tuple with one element, another one element. Okay. So connect have only one parameter here. Okay. The parameter is a tuple. That's quite important because if you lost one parenthesis, one pair of parentheses here and here, the function will be report some error message, and you will be maybe you may not continue like for other part of your programming. So this is the usage of this connect function. Okay. So this page is the continuation of the previous one. If the network connection cannot be made successfully, an exception is raised. Once a connection has been successfully established, a socket can be used to send and receive data in the form of string. The same method is used to transmit data to the remote host. This task, this one takes a simple parameter to that is a string to be transmitted. This works in much of the same fashion as the write method for writing to the file. If we expect to receive data from the remote host, we can call the receive method. As this. This RECV method returns a string of characters. Although somewhat analogous to reading from the file, the precise use differs due to the nature of the network. Firstly, a parameter must be specified when calling this RECV receive function to point out or to designate the maximum number of characters that we are willing to accept at the moment. This is not possible to accept an unbounded amount of data at one time. When the call to the receive is made, there are 4 possible responses. The more natural is when the call returns a string of the indicated length. In this case, there may exist additional data sent through the network, yet no return by this code due to the specified limit. Such further data is buffered by the socket instance and returned by the subsequent call to receive. Another scenario is when receive returns less data than the specified maxima, presumably because no further data has thus been sent by the remote host. A third scenario occurs when we call receive, yet no additional data is currently available, rather than return empty handled. This call waits unclearly or indefinitely for more data to be received through the network. So this saves us the trouble of making multiple calls while waiting for the expected transmission to arrive. Yet this can cause trouble when the remote host has no intention of sending data. Consider this example, that final call to receive never returns. Although we establish an initial connection with the web server, that server does not bother to send further information. In this example, if we connect to this website security.edu.cn, if we do not send anything to our host, what's the problem? Oh, it's okay. And this host will know send a lot of things to the to our client or to our computer. This is precisely why network protocols are so important. Both the participants must have a clear understanding of when each is to send data. Like in this time, we are just connect to the website, and there's no reason that the website will say anything to you or to your computer. Okay, but maybe some kind of host or some kind of server may have a mechanism that if you connect to that host, to that server, they will immediately send something to you, like send some kind of information about the server, about the host to you. But there's not always this kind of thing. So that's the reason that we usually need a protocol. Okay. Both the participant must have a clear understanding of when each is to send data and the format used for transmitting the information. If the software on the two end does not cooperate properly, the communication will not succeed. Another scenario, the last scenario of this kind of network connection is in which a call to receive return an empty string. This indicates that the connection has been closed, either by the remote host or the network disruption. So there is no reason to continue waiting. We can terminate a network connection from our end by invoke the close method. close means I haven't framed that method here, but it's like as though close. Okay. Once we have closed a connection, any subsequent call to send or receive will result in an error. Okay, and this is a table list of the Python's socket class about the selected behaviors on prototypical instance of S, like S to connect, S to send, S to receive, S to close. Okay, as we have mentioned before, the connection have one parameter, but this parameter have a very exact format, host and the port as a tuple, and send function with a string as the inputting parameter, and receive function have a inputting parameter of maximum number of characters. And another one is close function. Close function disconnects the socket S from the remote host. Okay, so this is the behavior of socket class. Okay. And next topic is to write a basic client, web client. There are several models for network communication. The two most important or most common models or methods are the CS model. The CS model means the client server model, and the P2P, peer-to-peer model. I think we have here, we have heard a lot of like this kind of thing. Maybe CS is an out-of-date term, CS architecture or CS model. It should be like maybe 10 years ago or about 15 years ago. It's quite popular to like make everything to be a CS architecture, put every software to be the CS. That we have a server, and the server can do maybe low level operation, and you have a client like a terminal in your side, that will display have a better, beautiful appearance, and so on. Peer-to-peer should be another model for communication. Okay, in the CS model, client-server model, the two connected machines have a very asymmetric role. A machine acting as a server typically sits passively, waiting for the client who initiates contact. For example, a web server does not do any work unless someone makes an explicit request to receive content from that website. But the protocols used for the CS model typically involve the client sending a request and the server sending a response to that request. So that's the protocol of CS model. Usually that like this kind of thing. For this reason, the software for controlling the client is usually different from the software for controlling the server, because they are like asymmetry. So they are different from the client end and the server end. But in the peer-to-peer network, two connected machines have more symmetric capabilities, and thus each run the same software Peer-to-peer P2P software is often implemented by combining the separate capabilities seen in client software and server software. When they were using whether you are using client server or peer-to-peer model, it's critical that the clear protocol to be used for any network connection. In this section, we begin our examination by demonstrate several simple examples of client software for existing protocols, specifically accessing like a time machine, a time server, and accessing a web server. In the following section, we will give several examples of software written to support the server. In later section, we will combine these techniques to produce more robust applications. Okay. And this is the example of write a basic client of get some information from the time server to fetch the time and date information. For our first client program example, we use the internet to figure out what time is it. The National Institute of Science and Technology (NIST) should be like something in the British or United States, and it runs servers that when queried, it will report the current time. These servers are connected to atomic clocks, so their time is precise. Although the time when it's received may not be precise due to network delay, because like if the information is precise from their end, from their side, but because of the network delay, it will be not so precise. So I don't know the meaning of that, but it seems like the but if you can have a very fast, or if you can precisely calculate the network delay, that will be useful. Also useful. You can just subtract the network delay by the time you get, by the time you request. Okay, and our reason for using this as the first example is that the time servers support a very simple protocol on port 13, known as datetime. This one is very important protocol here, and I think a lot of application, especially some kind of synchronized application. That would be like some server and client synchronized function. They will be all based on this protocol with the port of 13, because they all fetch the date and time information from this server. If they find like the time and date is not the same, which means they are no synchronized. They are not at the same time, and there will be some problem. Okay, like in some application, like the internet clock application in your smartphone, or in your computer, like in your Windows, you have a time clock. That time clock can be connected to the internet. So this is the basis of the service that you may use in your computer. Okay, the time service. whenever the client opens a connection to one of these time servers, sometimes they use different, maybe several several server in different location of the world. And whenever you connect to one of these servers, the server immediately returns a string that contains the time and date information. The client need not even send an explicit request. The mere act of the opening connection implies that the client desires to know the time because they connect to the time server. So there's no other purpose. You are not trying to like say hello to the time server. You just want to know the time, currently time. Like if you like watch your like a traditional watch. I mean, that's the only purpose you watch the watch. That is, you want to know the time. Okay, so the client need no even send an explicit request. There will be the server will return the information of time by the daytime protocol. And the format of the daytime protocol is like this one. They are a string. This is a string, and they provide some information about the current time, day, and some other information here. The full specification, I mean, the full specification of this protocol are documented by NIST, but the key information that we need is present, which the second field of the string is the date. I mean, this one is the date, and this one is the time. They're quite easy to understand, right? In YY year /mm/dd, years and months and dates format, and the third is the time in hours, minutes, and seconds format. The time zone for this date and time is universal time, which is the time zone of Greenwich, England, in British, right? We know that the time zone, the UTC, is in the Greenwich in England. Okay, so if you want to know your local time, it's better to use some method, or you can just subtract or plus the time difference between your time zone and this universal time zone. Okay, and let's try to find out what time is it by opening a connection to one of these NIST server manually in the interpreter. It's not very difficult to do that, but I can try this one as a demonstration. Firstly, let me like spider. Oh, it's better to use Anaconda. It's okay. Maybe it's not necessary to open the slider. And this one is another like a command window for Python. And in my computer, I have TF. This one is the environment of my Python. And firstly, let's try to do something from socket. Import socket. Sorry. Python from socket import socket. Okay, and the connection equals socket. We create a socket and connection dot connect what? Connect the time.nist.government. GOV is the type of government, and 13 is the protocol of daytime. Okay, because we have already connect to this server, we can receive some information here, and we use the print function, and it's to be point that for Python 3, we have to use this one. Maybe string is not necessary, but string is necessary and print is necessary. Okay. It will return this information, and after we connect, after we receive the information, we have to close our connection. So this is the source code for this socket, for this time query application. We create or we instantiate a socket class and connect to this website with this port or protocol, and we print the result from the receiving message. Okay, and you return this one. This B means bytes, because internet always transmits message with bytes, not with string or not with like integer. They use bytes to 1 byte equals like 8 bits to transfer to transmit the messages. And actually, this one is a string with this information. Currently, is just 2020 July the 11th. Current time is this time, because this time is different from our time zone, so we can try to we can only know the time in UTC, so this is the time. Okay. After that, we will disconnect our connection, our connection to the time.nist.gov government. Okay. The previous example provide like a command, several lines of commands to fetch the information of time and date. And we can also write application or write a function in our py file, also provide information like this one. And this page provides this example. This one is a self-standing client, for retrieving the current time as shown here. Notice that we use split to break apart the server's response. The servers receive information upon the white space, upon the space, okay? And then retrieve the relevant portion of that string. If we prefer to display the data with a different format or to change the time to the local time zone, we could use some kind of tools from the time and date time models. We have some models in Python to provide, like, to calculate different time in different time zone. So this is also possible. Okay. And this example is quite easy to understanding. Previous 1, 2, 3, the same In the fourth line, we use the split at the end of the received information and separate the previous string into several substrings, and we find the date information in the second substring and time information in the third substring. So after that, we can print the information of date and the time here. Okay, this one is quite easy to understand. In our previous example, the second example, we developed that client that download and save the information of time. But the protocol for retrieving a web page is more complicated, and we have to implement that as another example here. Okay. And the protocol for retrieving or fetch a web page is HTTP, as we mentioned before. This kind of HTTP protocol is displayed as here. But I think maybe the information, I think the picture here is a little bit too not very clear to be seen here. I can make it larger. Like this one, this version, it should be like 1.0 of the HTTP protocol. It's not the most current version of the HTTP, but it's a simple one and still supported for backward compatibility by many like web servers. So to request a page, the client will have to send a GET message to the server. For example, like the get the index.html. HTTP 1.0 ask the server to send the index.html page using the version 1.0 of the HTTP protocol. That can be found here, not here. Okay, but this is the head of the HTTP protocol. HTTP 1.0 and 200. Okay, and they server content length and content type. They provide information about the whole HTTP information here. Actually, the information is HTML. We have this kind of information here. HTML means the hypertext makeup language. It's kind of language, one kind of language here. Okay, and to request this page, we need some information like get function, get index.html with the version of HTTP 1.0. If the indicated file is available, the server sends the contents of that file back to the client over the connection. If the file is unavailable, the server sends an appropriate error page, like 404, 404 error, or some other kind of error. Okay, according to the HTTP protocol, the precise data sent back by the server contains not only the contents of the web page, but additional header information, such as the file type as we display here. Maybe it's a little bit simple. You can see that from my PDF file. Like the header of the HTTP and information, some kind of other information like file type, last modification time, and length of the file. Okay, and the contents of a header differ somewhat from server to server, but the typical response is shown here. The header begins with this response that indicates the protocol being used and the success code for the indicated page. Success code is 200. Okay. The header may include various other information and finally is guaranteed to be followed by the blank line. What makes fetching the web page more complicated than fetching the time is that the length of the response varieties. For our purpose, the most relevant piece of information within this header is the content length. In this case here, which means the size of our information. This one, this 19.4, okay? Remember that when we call the receive method, we are required to provide a limitation on the maximum amount of data that is to be returned. So if we know the overall length, we might be tempted to try to receive the remainder at once, but we have no control over how quickly the data is received through the network. Instead, we read a little bit of the response at a time, keeping track of how many characters of content we have read. We continue doing this until receiving the full content length. So this is the way, like some kind of progress bar. If we have already know the maximum number of content here, and also including like current, we have load how many characters, so we can provide this kind of thing for you in many kind of web browser, right? You see this kind of thing. The progress bar here. Okay. And this is a complete program about the connection of the server server to provide the single web page and how to provide the web page or how to save the contents but know the header to the file. Okay. Okay. Because this example includes maybe a lot of information, and I don't think we can finish them in today's lecture. Okay. Next one should be implement the server. Another way to implement. Okay, so we can today we can just stop here. In next class we will start by explain that this complete program that to provide a server to download a single web page and save the contents to the file. Okay. Yeah, today we will stop here. Okay. Okay, and class is over. You can go home. And later I will send I mean our record video to the YouTube. Yeah, but maybe
thank you.
After several days, we have to. I mean, we link have to encode the information, encode the video firstly, for several days should be. Okay, you can go home. Okay, see you everyone.
I have one question.
Oh.